All right, so we're live now. So this is a review problem. Today's date, January 7th. I'm getting you people ready for your upcoming assessment. So I'm going to use synthetic division to find the remaining factors. There are 3 of them. I know there are 3 of them because it's a degree 3. Okay, so I take the constant numbers, 1, 5, 7, 3, 1, 5, 7, 3, or the coefficients. They're actually called coefficients. We put a little sideways bracket right there. All right, Ms. Crum, what goes in that sideways bracket? -1. This is called the root of this factor right here. So that's the factor. And the root would be -1. Very good. All right, now all you got to do is just follow along. Ms. Finley, the rules are if you get the question correct, you get the bonus point. You keep track on your own little paper up top. You show me at the end of class. I can add them right now or the next day of your choosing. If you don't know an answer, you can simply pass. So my question to you is, I got to put a number right here. Do you know what that number would be? Not 0, it would be a 1. Landon, I need to put a number right here. What would that be? It'd be a -1. You multiply these two to get this number, okay? Lane, I need to put a number here. 5 minus 1 is 4. Matthew Gordon here. Very good. And Miss Patton right here. +3. Gradolf right here. -3, that gives me a 0. This is called the remainder. Once again, you don't always get remainder 0, but it's helpful when we do. All right, round 2, Mr. Fox, I need to rewrite this guy as a trinomial. Can you do that? You pass? It would be 1x squared plus 4x plus 3. This will always be 1 power less than what we begin with, and we began with a degree 3. So I have a degree 3 here. So when I take a factor out of it, you see I'm taking this factor out of it, that's going to leave a degree 2. All right, now your job is to factor this guy. LD, can you factor this for me? No. Ms. Crum, x plus 3, x plus 1. Well done. 3 times 1 is 3. 3 plus 1 is 4. That is done. These are my factors. I've just found them. I have nothing else to do except put them up here in the little box. Where? Positive, positive, positive. If these are all positive right here, then these factors must be positive also. Say that again. Yeah, if I wanted to find the 0, so these are my factors, and if I asked for the roots, then you would say this one is -3, this one is -1, and that one is -1. Now, just for some more practice, let's graph this function. Okay, so you can see my roots. So this is my XY axis. okay? Ms. Crum got the last point. Ms. Finley, do you know what to do next right here? The first step to graph this little problem. What we are graphing is, we are graphing the function up above, which is this and that. So what we are saying is that if I gave you this function, you should be able to turn it into standard form, which would be this function. If I give you this function, you should be able to go backwards and write it in this form. This is called factor form, and this is called standard form. So we are graphing this, really this. We've done the work. Now we have to do something on that axis. What do you think? Say it again. Put a point up there? How many? I assume you mean on this x-axis, right? How many would there be? There'd be 3. Very good. Add yourself your points. So one of them is -3. One of them is -1. The other one is -1. 3 roots, 3 points. This is called a double root right here. All right, my next question. Landon Mullis, can you describe this function? Your choices are, I'll put it up here on the board for you. Your choices are positive odd, negative odd, positive even, negative even. Which one? Negative odd. Let's see, you said negative odd. Odd, 1, 2, 3, 3 roots, 3 is odd. It is odd, but the lead term is positive, so this is actually a positive odd. Over here, I will say positive odd. Right arm up, left arm down. We have this also could be that squared. We got a bounce. And we have a go through. So the bounce is going to look like this. We bring this down. It's going to hit this guy, and it's going to bounce off like a trampoline. And that's got to turn back around and come down like that. Okay, a couple more free points. Miss Goodwin, there's a little point right there. What do we call that point? 2 words, starts with an R. Very good. Mr. Gordon, what would this one be called in relationship to hers? This one is a relative minimum. All right, that's a pretty good little review right there on how to find factors and how to graph a polynomial function. Okay, remember to get your little 10-point credit on this. It's not an assignment. You don't want to do it, don't do it. You want to do it, I give you credit for doing it. Okay? Now we'll flip her back over. Now we're going to try to kick this side out. Let's see. Might as well just start right up there at problem number 3. I want to write the equation to this graph, okay? So when you write an equation, you need to figure out what the factors are. Miss Patton, can you tell us one of the factors? You are correct. Miss Gradoff. You are correct. Are there any others, Miss Gradoff? What? There's another x minus 3. There are two of them at x minus 3. So if there are two of them there, we simply put a power of 2 up there. There are two of them. That gives us 3. Two of them here, one of them here. So I have 1, 2, 3. It's a degree 3. So over here, you would write y equals x plus 1 times x minus 3 squared. And that is it. It doesn't say write it in factored form, so you don't have to multiply that stuff out, although you could. You should be able to, but you don't have to.
So I have a question.
Yeah.
If there's only two factors, then does one of them have to be squared?
That's a good question. And she said, if you guys didn't hear it, if there are only two factors, does one of them have to be squared? Yes, if you, can you see my cursor? You probably can't.
No.
Okay. I don't know. I can't annotate on top of this unless I try to share this screen, and I don't really want to have to do that. But there's a little, if there's a bounce right here. As this comes down like this, this tells you there are two of them. And this one over here, if it goes straight through like this, one factor, two factors. Okay, did I answer your question?
Yes, thank you.
All right, good, good, good. All right, let's move on. Let's go to number 5. So there's number 5. For you people at home, I'll give you some time to write her down. Okay, it's a pretty good problem here. You have to be able to graph it, list the zeros. Let's see, who is up? I think I left off with, I don't know. Who did I leave off with? Who's the last one? Give me the correct answer. I forget. Gordon? Oh, okay. So good when you're up. Huh? Oh, it went you, then Gordon? All right, Miss Patton, what are my zeros? -2, 3, and 3. Very good. Back to you, Miss Gradoff. I need a y-intercept, please. I'll give you a moment to think about it. I'm sorry? Okay, y-intercept. Put 0 in for x. And multiply. So I put a 0 there. Put a 0 there. So what do I got? 2. That's -2. That's -3 squared is 9. I think it's -18. Okay, end behavior. You can't really do the end behavior unless we describe the function. Mr. Fox, what do you think? Positive odd, negative odd, positive even, negative even? You are correct. Negative odd. Now, we got to graph this guy. Laurel, what's my first step to graph this thing? Yeah, or tell me, yeah. A dot? In between 2 and 4. That's good enough. Negative odd, looking up there at the board. Left arm up. right arm down. Go ahead. You guys graph it, walk it up and show me. I'll give you 60 seconds. If you can do it in 60, you know how to do it. If not, then just all right, let's check this out. Not bad. Not bad. Here's what I do. I put my arms up, down, because I know that it's negative odd. Here, this one. So then I'm going to, the bounce is occurring right here. There's the bounce. So the bounce has to be right here. So if I come this way, it's got to look like this. And it's just a sketch, so that's going to come all the way down to negative 18, but I don't really care about that. And then it's got to come back up like that. All right, pretty good. Go ahead and kick out problem number 6. Okay. I want to see if you can do some calculating on your own. Walk it up and show me when you are done. Let me see yours, Miss Patton. You're good. That's good. Getting the answer there pretty quickly here. That's good.
So here's the practice test.
Yes. Yeah, right in the center. Put them equal. Get everything on one side.
Okay.
Yeah, you did, but there's something you're not seeing. See this right here? What is that? Which is? Six. Multiply that, you get zero. So this is zero. So now, just focus on that side.
So I would subtract zero.
Yeah, so you can put that. That one. Okay. All right, people at home, anybody at home get an answer? Anybody? You can chat it in if you like. Chat line's bare. I'm waiting. I got one in from David Perry, Abby Niebert. I got 2 people in. I've got 2 people in. I need 4. 2 people are in. I need 4. David Perry is in. Abby Niebert is in. 2 more. Okay, can't wait anymore. Here we go. Here's how you work this problem out. It's not as difficult as it seems. I don't think our success rate was great, but I want to simplify this problem. Really, this is an algebra 1 problem. I just want to plug 3 in for x. So 3 minus 2. First thing I recognize is I put a 3 in here, I get a 0. So this wipes out all this stuff. This is 0 because that's 0. See? 6 times 1 times 0 is 0. So I got to work on this side. So I have 4, 3 minus 2, 3 minus 5, 4 times 1 times negative 2 is negative 8. Negative 8. All right, let's move it to number 4. Let's get this guy out of the way. So when you list these points, I want letters. I want the letters or numbers. Letters? Typically, I want letters. If you can't use the letters, then we're going to go with numbers. So I am back to, I can't remember who gave me the last one, the last correct answer. Where did I leave off? I left off with Laurel, so I'm Miss Crum. Miss Crum, can you list all the relative minimums? Check. List all the zeros. Miss Finley. You said H and what? We should have said the zeros are the same thing as the roots, which would be A, C, G. All relative maximums, Landon. Okay, the relative maximums are points where you can stand on little mountaintops. There's one at F and there's one at D. D and F. I need an interval where f of x is positive. Lane, good one. No, just 2 letters, an interval. Like an interval could be from, like right here, 4 through 6. That is an interval. So I need 2 letters of an interval, typically x values on the x-axis. C and what? C and D. The correct interval is where f of x is positive. All of it is positive right here. It's all above the x-axis. So C all the way to G. There is another positive interval. The other positive interval actually goes from, this part is positive, so technically it's negative infinity all the way to point A. If you wanted to list that one, you could. Negative infinity to A. And Mr. Gordon, what about where it's negative? It is negative right here, this little dip, A to C. Check. Well done. All right, let's bump her up to number 2. On number 2, you have to find the solutions. Miss Patton, you're up. What can I do? You pass. Miss Gradoff, what can we do? Say it again. No, we don't want to find the zeros. What are the solutions? Write it in standard form. Go ahead. So we got to FOIL this thing. Now, Miss Gradoff, do you use the box method or just straight out FOIL? Go ahead. All 4 terms. Hold on. Keep going. All right, you're good. Mr. Fox, you're up. What would you do next? Go ahead. You're good. Back to LD. What would you do next? You pass. Miss Crum. Tell me what to write then. You're pretty close. I don't know. I can't exactly hear you. Let me do this. Let's do this. What I'm going to do is I'm going to put an equal sign in here. You tell me what goes on the left side and you tell me what goes on the right side, if you can. On the left side, you're correct. Very good. But you don't have to put that plus 0 in there. All she did was whenever we solve these things, we have to have 0 on the right. So I added this 15 to both sides and they just cancel out. Very good. Rhea, what would you do next? Pass. Landon. Want a clue? Starts with an F. Miss Goodwin? Can you factor this? Pull out an X. You are left with X plus 2 Set them both equal to 0. There's one. Set the other one equal to 0. And do the math. There's the other. Pretty good. Got one more to do and we're going to be called a day. Find the points of intersection. We've been doing this for quite some time. Points of intersection. We've been doing it this week. We did it prior to Christmas. You should have an understanding of how to find intersection points. Back to you. I don't know who gave me nobody factored it. So I'll start back at the top. Grade off. What do you do? Step 1. Louder. Put them both in standard form, but before we do that, we're going to say G equals F. Now we put them in standard form. Left side, Mr. Fox, you work on that. Right side, LD, you work on that one. Give me the 4 terms, Mr. Fox, whenever you're ready. LD, whenever you're ready. Okay, what he's doing this in his head. He's going to go, I'm going to write it out for you. 5x minus 2x. And then what's your last term there, Mr. Fox? Minus 10. So that's x squared plus 3x minus 10. All right, LD, how about your 4 terms? That's one. That's one of them. That's one of them, and you're missing one. All right, clean that up. -4 plus 1 is -3. Okay. Now your job is to get everything else together on one side. So I'd take the stuff on the left, bring it to the right, set it equal to 0. All right, Ms. Crum, you're up. Start off with the squared terms. What happens? Combine them to what? What we're going to do is we're going to subtract that one and subtract it over there. So 2x squared minus x squared is 1x squared. Miss Finley, what happens with the next 2 terms? What do they become? So what, it would be what? 0. I'm going to subtract 3x on both sides. So this is -3 and -3, so I get -6x. Mr. Mullis, what about the other 2 numbers? I'm going to add 10. -10, +10 crosses off. -2 plus 10 is 8. And then I can set that equal to 0. Ms. Goodwin, what do I do with this trinomial? Starts with an F. Can you factor this?
3
Multiply to 8, add to -6. Gordon, Mr. Gordon? No, I'm just taking this trinomial. I'm going to factor in the two binomials, and we're halfway done. We just have to find these two tail numbers. This number and this number have to multiply to that number, and they have to add to that number. Ms. Patton.
-2 and -4.
Then you just set those equal to 0, and then you can find the points of intersection. So add 2. Now remember, he has a partner. You got to find that y guy. The other x value, x minus 4 is 0. Add 4. So x equals 4, but he has a partner. So we have to find the partners. I'm going to let you think about it. If you think about it, if you can see one, raise your hand. We'll try it. Just to find the y values. Take the x value, plug it back into either one of your choices. I got a line here, a graph here, and a graph here. I'll find the y value. I take the x value and plug it in. I'm going to plug it in here. Well, hey, here's 2. 2 minus 2, that's 0. 0 here times, well, it doesn't matter what that is. It's 7. 7 times 0 is 0. So 2 0. 2 0. Nobody got the other one yet? Plug it back in the same one. Over here is kind of longer on this side. Okay, that's 4. That's 4. It is 4 plus 5, that's 9. 4 minus 2 is 2. 9 times 2 should have 18. I'll write that out for you. You people at home are still watching and you can't figure out what I did. I'm taking this 4 and I'm going to plug it in. Plug this 4 in. Right here. 4 plus 5. 9 times 2 is 18. Okay. Pretty good little review. You people at home, I'll see you tomorrow. Okay. You can check out. Make sure you have copied all this stuff down. So therefore tomorrow you can transfer it back over to this sheet from January 7th.